Good afternoon, everybody. My name's Pete Lang. I run sales for a company called Brookstone Homes. I'm in my 9th year in new homes. It's all I've ever done. I got out of engineering school in 1990, went to work in customer service for a big public home builder in Chicago. Spent most of the first 12 years on the construction side of the business, troubleshooting, problem solving, trying to make customers happy, figuring out what goes wrong when buildings are put up in incorrect fashion. Last 6 years I've been running sales, so I do a lot of speaking and training on topics of sales, topics of construction. Here to talk to you with Jim Knapp this afternoon. We're going to talk to you about creating a drainage plane. And I want to start just by giving some of the background and why do we need a drainage plane and why is this a new concept and what is it. So, 50 years ago, we didn't really talk too much about drainage planes. But builders knew an awful lot about them. 50 years ago, builders were much smaller organizations. A builder or a master craftsperson, a company who built a house might be just a handful of people. And you had trained, skilled people doing lots of aspects of construction of the home. As such, if one person's doing the framing, exterior sheathing, windows, doors, siding, flashing, by nature, that person would understand a little bit better how all those different components interacted. The other thing about houses 50 years ago is houses were drafty. When water got into a house, drafts generally pushed the water back out. We didn't really have to care so much about how wet a house would get. Today, things are totally different. Builders are now an organization with typically a few people in charge, directing the activities of many companies and many other individuals on the job site. Now one company might frame, one company might sheathe, one company might flash, one company might install windows and doors, and we have less understanding of how all those products interact and behave. We have less understanding of what we need to do with those products to keep water out of the wall. Coupled with that, we now build a wall that cares an awful lot if it gets water in it. We now build a wall that's not drafty and leaky. We now build a wall that's packed full of insulation, and when it gets wet, we've designed it so air doesn't blow through it, it stays wet. So now we have to care about how water behaves on the outside of a structure. We have to make sure we put the components of the building together in such a way that water that wants to get into the structure doesn't get in, that water gets to the ground. And so we have to discuss the concept of a drainage plane. Our goals today, help you understand the building envelope, understand the outside package of a home or any building, understand what water intrusion and moisture migration do to us today. Again, old houses, walls were kind of empty, a little bit of water might have leaked in, plenty of air blew through it and dried it right back out. The house was very sort of resistant to that, didn't care. Today it's a total different deal. Identify the potential liabilities and solutions for typical wall assemblies that we see when we're putting a home together. And really overall, understand the proper installation of a water-resistant barrier, or what we call a weather-resistant barrier, or WRB. I'm going to let Jim take over and talk to you a little bit about that building envelope.
Great, thank you, Pete. All right, a brief introduction to myself. I understand that Scott this morning had an introduction with our bios for both Pete and myself. My name is James Knapp. I work with Hallmark Building Supplies. Hallmark is an integrated system of sales, marketing, and distribution. In that company, I'm the Vice President of Construction Products. I've been with Hallmark for 22 years. I was actually, as a salesperson, I was one of the first persons in this market to be able to have the opportunity to educate the building trade on using a house wrap. Back about 22 years ago, I can give you some data because I remember what it looks like. About less than 2% of homes were actually using a house wrap. A small percentage of that were using felt on the walls. Obviously, felt is used under the roof. Pete is going to kind of lay that out for us. Now, house wrap is standard building practice. It's just a standard building practice. And through that process, we've educated a lot of people in the trade, including many of you, on how to properly install these products. The key to those products are being able to use a system of products that are engineered to work together, that chemically bond, to create a monolithic envelope which protects the builder's home, which limits the liability of everybody because it reduces callbacks. Now, in order to kind of understand where we are today, we thought in developing this, it would be very interesting to look in the rearview mirror and go back into history and understand how we got to where we are today. So the first thing that we want to talk about is a little bit of history of the house wrap and kind of where it came from. I'm going to use this whiteboard here to illustrate it, but the company that brought house wrap is DuPont. DuPont created a product called Tyvek over 40 years ago. Tyvek was originally brought into the marketplace as a protective material that protected a lot of different things, not houses. It was protecting, it was a FedEx envelope. It's a protective material that's used in medical packaging, apparel, waste removal suits. Because of the properties of this product, they innovated this product that we can use it in the trade to protect homes. The reason being is it's air resistant, water resistant, so it protects a document in a FedEx envelope, but it allows moisture vapor to escape. So DuPont created this category called house wrap over 30 years ago. Now here's where it was created. If you think about a wall, it was created, house wrap category was created, and this illustrates my wall. So house wrap category was created to protect that wall from outside air infiltration. And the belief was that if we wrapped our exterior wall, which was defined as our building envelope, we could protect the wall from air infiltration, making the home, obviously reducing drafts, more comfortable to live in by stopping air infiltration at its source, making the energy bills for the consumer a lot more comfortable to live with. So for the last 30 years, we've been saying that this house wrap category will protect your building envelope, your wall, and reduce air infiltration. About 10 years after that, through innovation, what house wrap manufacturers started seeing was that they could take this house wrap, and the number one callback in the building industry is water-related issues. They could take this house wrap product, re-engineer it, and create a product that could resist air, resist water, and because it's moisture vapor permeable, which means it allows moisture vapor in a molecule form pass right through it so it can breathe, it can stop air, resist water, allow the wall to breathe if moisture does get in, and we would have an air-water barrier and be able to solve issues for the building trade. So the house wrap category, really the job of this WRB is to stop air, resist water. But when you're stopping air and resisting water, the reason you don't want to wrap with a plastic film is it needs to be permeable. The higher the permeability, the greater the confidence in the building trade that moisture, if it does get into the wall system, it's going to be able to escape. Okay, so DuPont created that product. Now here we are today. There's about 70 products in the marketplace, choices of house wrap to wrap their wall. But here's what we need to think about. When you're looking to wrap your wall with a house wrap, a WRB, to create the drainage plane, the first thing you have to ask yourself in the trade is what type of exterior facade do I use? Because depending on the facade, house wrap manufacturers today are bringing more to you than just a house wrap. They're bringing products that actually provide thermal performance. The key that Pete's going to clearly define in the installation process is that we want to create not just a product that stops air and resists water, but understanding that the innovation of all these new products from where we've come from in the past, we have a lot of products to choose from to make these houses look pretty. And as we choose these exterior facades, we want to build in not only a product that resists air and water, but we want to create that vertical drainage plane. So house wrap manufacturers have gotten all over that, and they're bringing more than just a house wrap today to the trade. They're bringing products that have thermal performance, insulating house wraps that can give you some R value, house wraps that are creped, that create a drainage plane. Let me kind of introduce what I mean by that. So the first thing I have to say before I choose the right house wrap and the product within the brand is, if I'm using vinyl siding, what are my choices? Well, there's always been felt, 15 or 30 pound asphalt impregnated building paper. You got home wraps. You could use a thermal performance metallized coated home wrap that actually gives you low E. So as a builder, you can choose, You know, everybody knows the concept of low-E glass, right? Well, there's actually house wraps that give you a low-E wall. And if you're performing, if you're building trade and within your product and you're marketing homes that are energy efficiency or green initiative, as Tim was just speaking about, you may want to consider a house wrap that it has thermal performance to it. So not only does it stop air and water, but it also gives you thermal performance, not only a low-E glass, but you can have low-E walls using a thermal performing house wrap. Under a brick facade, actually, if you use that low-E thermal performing thermal wrap, you can also, with an adequate airspace, gain an R value of 2 with an insulating house wrap. Under fiber cement, the trade has been using either a felt building paper or a home wrap or a house wrap. Now, innovation has brought us to a house wrap that actually has crepes in it. And the purpose of that is when you put vinyl on the wall, it hangs loose. So it creates a natural drainage plane behind vinyl siding. But when you put fiber cement on the wall, it's hard sunk to the wall. And as water runs down that wall system, as Pete's going to clearly define, how do we put all these products together to get water to run down that exterior envelope and out to daylight? As we're putting hard fiber cement up against that wall system, it can create a horizontal seam. So the value in using a house wrap that's creped, like a drainage wrap, is going to allow moisture to drain 100 times greater than building paper or a traditional house wrap, home wrap product. Under manufactured stone, actually the code is going to be calling for 2 layers of a building paper. There's actually house wrap manufacturers that actually are now engineering a 2-layered system that you can, from an installation perspective, do a 2-layered system in one step. Traditionally, what I see people doing today is either they're using a 1-layered system, or sometimes they're using a building paper like a felt, or a home wrap product, or a stucco wrap product. House wrap manufacturers are going to be introducing very shortly a 2-layered system that's going to make it easier from an installation perspective. Because whenever there's direct applied mortar to any building paper, it can reduce its water holdout capabilities. So by creating a 2-layer system, there's more confidence for you that we're not going to have any type of litigation or callbacks that moisture has entered the wall cavity, even though you're using a building paper. So you want to use 2 layers. Under a stucco facade, whether you're using the EIFS systems or a traditional 3-layered stucco, you'd want to use a creped product that literally creates a drainage plane behind this either EIFS system or 3-layered traditional stucco system. So it's not as easy as just saying, I use, you know, like Pete said back 50 years ago, I'm using building paper. Innovation of new facades and new building industry and building products in this industry has changed the game, and these house wrap manufacturers have answered with a solution of products that create that vertical drainage plane. So the first thing we have to say is we're going to wrap our wall, which is our building envelope. We're going to create a vertical drainage plane. What type of facade do I use? Choose your WRB based on what type of facade. Learn about the different offerings that are available. Okay, the building envelope. For over 30 years, the building envelope has been defined right here, the wall. But actually, I can show you where it's going. I sit on the council for the leading manufacturer in this category of innovation and technology, and I can show you where it's going. Because for over 30 years, we have defined the building envelope. We taught the trade the building envelope was the wall. And we said, based on your wall, you need to protect your wall because it'll limit your liability by reducing water potential callbacks. Actually, now what we're realizing is that you guys are building a home as a system, or a building as a system, whether it's residential, new construction, remodel, or commercial. And as we look at that system, we realize that you guys are putting this wall on a foundation. And then this wall is also being capped, you know, with your roof. So we got a foundation, a wall, and the roof. Here's where the category of WRB is going: weatherization systems. for so many years, we told you that, use this house wrap and it's going to protect all your callbacks, help you build a better wall. That's true, but I think where you're going to see this thing going is the building envelope, first of all, is going to be what is traditionally defined right now as the wall, is going to be tied into the foundation, the wall, and the roof. The entire building is going to become the exterior building envelope. And where you're going to see these manufacturers start to bring innovation of products is based on the system of products that you're using. They're going to give you choices, like they're doing for the wall, to tie your foundation to your wall to your roof, and they're going to redefine this as the building envelope, the entire foundation, wall, and roof, and give you a system of products. There's already manufacturers that are bringing technology from Europe, and technology in Europe is actually using house wrap products that are metallized, thermal performance, because all walls in Europe are built with stone. They're actually, they don't wrap the wall because it's built with natural stone, but they use this sealed attic ventilated roof as one of the first innovative products that came to protecting heat loss, energy conservation, moisture issues, ice damming, solving problems for the building trade. So again, the envelope is going to go from defined as the wall to the foundation, wall, and the roof. Now what's been interesting here is what we realized is within this wall, the building industry is actually putting windows and doors. So for so many years, we would tell you, use a house wrap, wrap your walls, and we're going to protect air and water for you. And then make sure all these different people in the trade that touch that exterior wall, properly install this stuff, which is really where Pete's going to tee this thing up and show us the proper best practice in installing these products. But when we look at this, we realize that you guys are putting doors in, and you're putting windows in, and you're putting windows actually with like circle top or elliptical top or circle windows, and you're actually putting penetrations in that exterior wall. So house wrap manufacturers that once just brought house wrap as a WRB are now bringing a system of products. So as you look at your window and doors, there's some questions that you have to ask before you just say, I'm going to use this flashing product, or I'm going to use this caulk to seal all those penetrations. Because here's what's interesting. The average 2,000 square foot home has over 1/2 mile of gaps and seams where all these building materials come together. Those gaps and seams, because of pressure differences on the wall, air and moisture are going to pass through this wall cavity, through those cracks and seams, and get into the wall system, outside of the penetrations that we're going to make here. By choosing the right system of products from the top down of this building and protecting that envelope, when you get to your windows and doors, before you just choose a sealant or before you just choose a flashing product, what you want to ask is, what type of brand of window am I using? What's the proper installation method for that brand? What's the width of my wall? Is it 2x4? Is it 2x6? Because that will change the window pan or different products that you may want to use. And there's some windows that actually have a nailing fin. There's some windows that do not have a nailing fin, like a brick mold window or a brick mold door. House wrap manufacturers have actually innovated products that are flashing products that actually create a window fin by simply using a flashing product. There's a product called Straight Flash VF that actually creates a window flange with a non-flange window and door. There's three-dimensional products that can actually seal the bottom part of your window, protecting, because if water ever gets into a window opening, where do you think you find it? In the corners. So protecting that, you can use a three-dimensional flashing that can literally protect the inside, the bottom sill, and the face of the window. Bendable, moldable flashings that can do this circle or elliptical top window in one piece. They're actually products that have flexible materials in them that you don't have to cut in piece tin flashing or other flashing materials. You can, in one piece, go around these types of applications, protecting that. Now the value here, here's where I'd like to leave this part of my presentation and turn it over to Pete. Some things to think about. The building envelope is more than just the wall. Think of your foundation, your wall, and your roof as a system. We all know that. But choose a system of products, because you can take a house wrap, you can take a tube of sealant, a roll of tape, and a piece of flashing product, and you can put them together. But here's the key. They're not engineered to work together. Choose a system of products that are engineered to work together chemically, that chemically bond to one another, that protect your entire building envelope, that are engineered to work together, that the manufacturer is going to warrant for 10 years, protecting you from liabilities of moisture intrusion, at the end of the day, saving us some callbacks. Okay, I'm going to turn this game over to Pete. He's going to walk us through the drainage plane and the proper installation of these materials, because that's the key to making all of this stuff work. Thanks, Pete.
Thanks, Jim. Like Jim said, a product alone can't solve a problem. And like I was talking about years and years ago, you had fewer people involved in the construction of a home. You typically had a master craftsperson that understood various phases of construction and could handle the transitions when different materials went together and got put together. The players we have in the game now, we have a lot of manufacturers that make a lot of fantastic, high-tech, innovative products. And we have a lot of magazine ads that give us the impression that we'll buy this stuff and hand it to your guys out in the field and have them start putting it on the outside of your houses, and your houses will be better. The problem is, without understanding of exactly what that product does, but more importantly, how it interacts and how it connects to all the other products that we're going to put on the home, we've ended up causing ourselves greater problems than we've solved with just the choice of product. You can select the greatest products in the world to create an exterior drainage plane or a weather-resistant barrier. If you put them on wrong, you're going to have bad performance. Basically, you're going to have water inside a wall assembly. And water inside a wall assembly that stays there for a long time leads to the growth of fungus. Let's come out and say it. You can choose outmoded products. We talk about felt paper. Really, the first house wrap was felt paper, right? Guys put black tar paper over the outside of the house. And you can use primitive hand-bent metal flashings. If you put them together with a greater understanding of how those things work and how water is going to interact with those things, you can get a superior system. It's not the choice of product alone. It's an understanding of how these different components interact. Why did we do this? We're going to go through a series of slides that I sat on a panel here at MBA 2 years ago, and we put together what we called a weather-resistant barrier guidance document. We submitted it to the Department of Commerce in the state of Wisconsin because they were considering adopting some code language to mandate a weather-resistant barrier. Is there a weather-resistant barrier mandated by the Wisconsin Residential Code right now? Who knows? There is. You have to have a weather-resistant barrier behind your siding or your cladding materials today. Do you know what the acceptable form is? We should know because we see people doing it every day. Foam sheathing with taped seams is okay. And what we decided as a panel was we as builders have seen enough problems with foam sheeting with taped seams because tape doesn't stick forever in those assemblies. We've seen enough problems that there probably needs to be something more prescriptive. There's been nothing adopted by code. Commerce is considering adopting some of this by code, but the next series of slides is really what we put together and presented 2 years ago, and really best practices on how to create a weather-resistant barrier. There's no guidance in the code right now. There's no uniform specification for the industry. We wanted to make buildings perform better. Big thing, inconsistencies among installers in the field. We've got lots of different people involved in building a house. Depending on which state you go to, it gets even more specialized. You'll have one person put the studs up, one person put the sheathing on, another person put the house wrap on, a fourth person put the flashing on. And again, the next guy in doesn't know what the last guy did or really isn't concerned with what the last guy did. The next guy in's here to put his stuff on, and that's where we get into problems because there's not one uniform understanding about how these all exterior products interact. Manufacturers of exterior cladding products generally recommend or require a weather-resistant barrier. Jimmy showed us pictures of a whole bunch of exterior cladding materials. What do those cladding materials have in common? They all leak. I can't tell you the number of times I've been held up on a rough inspection. Mechanicals are good. Framing is good. Don't put any insulation in the wall till the siding's on. Why can't I put insulation in the wall till the siding's on? Well, because you've got to keep the water out. The siding doesn't keep the water out. All exterior claddings leak. Brick leaks, wood leaks, fiber cement leaks, Vinyl leaks. Vinyl's designed to leak. Look at the bottom of a vinyl panel. It's got little weep holes in it for the water we know is going to get behind the vinyl. Stucco leaks. Rocks leak. Your outside decorative material, Jim said, your pretty exterior is not there to keep the weather out. It can't keep the weather out. We have to design a system to expect water to get behind the exterior cladding. You have to have, now, will the exterior cladding slow it down? Of course it will. But you have to have a second line of defense. That's what this weather-resistant barrier, this whole gig, I could stop the class right now and say, if your house leaks with the siding off, your house is going to leak with the siding on, period. All the manufacturers say it. Vinyl siding has always been designed as an exterior cladding, not a weather-resistant barrier. This is right from the Vinyl Siding Institute. Designed to allow the material underneath it to breathe, not a watertight covering. To achieve design performance, you got to put it over something that won't leak. So what we're talking about is the wall behind the pretty stuff that you see from the road. And so anytime I get a service call and a customer says we were having Thanksgiving dinner and a storm blew in and my dining room window is leaking, well, we'll send somebody out. They just get and lean a ladder up on the outside of the wall and try to caulk the siding or anything to the exterior. They're not attacking the problem where the problem exists, because the cladding is going to leak. What's a drainage plane system? A system designed to shed bulk water while allowing moisture management from the roof peak to the ground. Like Jimmy said here, I love, for years and years and years, we've told you how to be a smart builder by showing you a wall and put some wrap on the outside of it. Problem with those homes is they're really dark inside. We're not dealing with reality when we draw a wall this way. There's holes in that wall, and customers pay more when they're beautiful looking holes in the wall. We've never taught you how to do that. And there's a place up here water's going to get on, and there's a place down here water's going to get on. So a system from the roof peak to the ground, integrating roof, exterior wall, flashings, penetrations, and cladding components. If we could build a wall like this and put some paper on it and never touch it again, we'd have leak-free homes. The problem is we build that wall and then we gash it full of holes. And it's how do we deal with the holes and how do we anticipate what the water's going to do. That's where the water's going to go in. Came in our dining room window. You know, it didn't just magically appear in the center of a wall where the wall was nice and solid and built like this. It came in through the holes. We got to manage the water around the holes. Good weather-resistant barrier, dams or obstructions, free flow of water, weep holes in masonry. These are some of the features we're going to talk about as I get into some of the picture slides to talk to you how this stuff works. Types of building wraps. I just want to say this. If you want to know how a drainage plane is supposed to work, just get up on the top of the house. It amazes me that we understand so well in Wisconsin how to make water hit the top of a roof and get from there to the ground. And suddenly we take that roof and we make it a vertical plane and we totally forget everything we know. Even the junior man in a roofing operation can tell you this is proper lapping of roofing materials. Shingling goes downhill. You'd never put shingles on this way. Why? Because water's going to get underneath them. And yet we get to vertical on the wall and we're doing it every single day. We go from sloped to vertical and we forget every bit of common sense we know. And so really, again, I could end the presentation right here. Build your walls like you build a roof, you're done. What kind of building wraps are there? Again, we'll go back to this. Well, why house wrap? Well, because houses are put together, the walls are sheathed with pieces of stuff. It used to be shiplap or tongue and groove, lots of pieces of board on the outside of the wall. Now it's pieces of OSB or foam sheathing, but they're separate units. They're 4x8 sheets, and we need something continuous. We need a plane. We need a flat surface for water to run down and not get into the building. So the best way to do that's with some sort of wide or long paper or rolled material. So that's where felt paper came in. 3-foot rolls, put it on. Again, as long as you shingled it properly, we're okay. And if you're going from the bottom up, you can generally achieve that proper shingling. So asphalt impregnated papers and felt, still a viable material. We're using it on our roofs. We're getting our roofs right. We usually don't have a lot of roof leaks around here. We have a lot of wall leaks around here. Spun bonded house wraps. Tyvek happens to be that category. There are a lot of perforated wraps out there that try to address some issues. And then the coated, like metallized or microporous films. So there's lots of different wraps you can use. I recommend using a wrap. The problem with foam and tape is there's not really any tape that stays stuck to foam in the long term. And ask any sider who's gone back to repair a window leak on a house that's got foam and tape, and the tape is all curled up inside the sheets of siding. Presto. Material selection and wall design, first step. Here it says, the best workmanship by the installer and the finest quality control of the general contractor will never rectify poor selection of materials and improper detailing. I agree with that, especially the proper detailing. Once again, the finest selection of materials, the most premium paid for house wraps and their integrated flashing systems and their high-tech sealants that chemically bond. If we don't know how we're putting them together, it's junk. Or if we don't use the whole system. I can't tell you how many job sites I've been on, and there's a couple of rolls of some tapey-looking stuff laying in the back corner of the garage. The flatwork contractor gets there, throws them out in the snow. Well, what are those? What are they for? The building's already sided. We got guys smiling. You've seen it. You paid for it, too, right? You bought it in your bill of materials, and now it's out in the snow. Well, we didn't know what it was for. We thought it was extra. We didn't know. If the stuff's not put together properly, you can pay all you want for a system. You can rip an ad out of a magazine on your way to Vegas this January and go, ha, that's what's going to solve my problem. You can start buying the stuff, but if your guys don't know how to put it on, how it interacts with the rest of the system, you're wasting your money, and you're going to have callbacks. So best workmanship and finest quality control never replace good materials. Best materials will never replace good workmanship either. So it's got to go together. Now we get into the fun part. The pictures, sort of the builder porn here. Here we go. I got Tyvek, I got FlexWrap, I bought the best system. What's the problem, though? The problem is this job is often relegated to more lowly skilled persons in the field. You know what? You just came on with us for the summer. I tell you what, your job's to go around and tape all the windows. Can you handle that? Can you not kill yourself taping all the windows? You know what? Your job's to look for missing pieces of Tyvek, cut a piece and put it back in. So we give this to a junior person, and this is what we get. Yeah, it's patched up pretty good. I got her done. I even used the fancy, expensive cap nails that my salesman told me I had to use, right? He gave me the gun as long as I bought those fancy nails. That isn't going to work. That's not a plane. So when we're talking about a drainage plane, it's got to be flat. It's got to be smooth. If water will run down it in smooth fashion and glide down it, you've got a drainage plane. If water's going to get hung up in different cracks and crevices, the problem with Tyvek, it's waterproof on both sides, man. So when water's behind it, now it's held in the building. It's waterproof both ways. So it's got to stay on the outside, on the business side of the Tyvek. Once it gets on the inside of the Tyvek or any building paper, now you've just given yourself a worse problem. Our company resisted house wraps for a long time because we said, if you don't put them on right, it'll actually exaggerate a leak. If it's not done right and it's not a complete system, it'll actually force water into your building. Don't ever do this. OSB is not a drainage plane. It's pretty flat and smooth, and it's kind of like got a smooth glue surface when it comes out of the mill. I can't wait to see what this looks like when this building is torn down. It's gray fuzz, gray fur. Water cannot run down the wall. I'm putting brick on the outside of it. Brick leaks. Brick is porous. Water gets behind brick. Brick was designed years and years and years ago and set up to where we held it away from the outside wall. There's the marker. Everybody knows this. Here's the wall again. Right? No windows, no doors, no nothing. And then I've got my foundation and brick ledge out here, and I'm stacking masonry up like this with what? That nice 1-inch airspace. And years ago, guys might put a piece of lumber in there and drag it up as they went course to course so that the inevitable mortar droppings that are squishing out the backside of the brick didn't fill this airspace up. You think that's happening today? No. So essentially what you're winding up with is brick and a mortar-filled space behind it, and this stuff is completely porous and water wicks right through it when it gets wet, and that OSB gets wet, and that OSB turns black, and that OSB rots, and it is not a drainage plane. There's no flashing system around that window. That's a very recent photograph. Where'd the cap go? I'll just sit here and sniff the marker for the rest of the class. Relying on OSB as a drainage plane with a brick facade, no flashing to deflect water away from window opening. So even if I did have building paper here or some sort of a weather-resistant barrier, I'm going to have problems with that window because it's not integrated with the wall. It's just slapped in the wall. And this ain't a cheap house, guys. That's a lot of money. Here's somebody using, again, expensive house wrap system, some sort of fancy foily kind of tape and stuff. I got a bunch of problems. Incomplete installation of a weather-resistant barrier. What do I have up here? Well, first of all, I've got probably a rim joist for the second floor, which, well, it's solid. I'm not getting any air or water through it, so my sheathing is patched with big gaps. That's not a plane. Water's going to go behind the cladding that's here. Water's going to hit that lip, and water's going to get sucked in. Period. The end. That needs to be completely flat, and it needs to be covered with this. What do I have here? I have the top edge, again, reverse shingling. Water goes down. Now water's going to get behind that thing. Like I said, it's waterproof both sides. Now it's in. Now it's trapped behind something waterproof instead of running out the surface of something waterproof. Why do we do that? We do that because of the history Jimmy told us about. This product first came to market as an air barrier. Exactly correct. So you'll see it today. If we were building more, you'd see more examples of it. It's a little harder to find houses under construction right now. But you'll see it right now. We go up to the second floor wall, and my gable end is bare. Oh, it's an air barrier. I'm not trying to keep air out of my attic. I put vents in my house to let air in my attic. Why am I trying to keep air out of my attic? Well, I'm not using house wrap to keep air out of my attic, but I am using it so that I don't just terminate the top edge and again have this reverse shingling, this bag now sitting there ready to catch water. Because water's going to get behind the siding on that gable end, and guess what? The gable end's usually sheeted with what? OSB, right? So I got a material that just should not get wet, period. The end has to be protected. So I got an OSB gable end, bare naked behind vinyl siding, water running behind it, and then reaching this wonderful situation, and we wonder why our customers are calling us with window leaks. So you got, if you're going to use this, go all the way. Make a flat plane, cover it with a properly shingled, this is upside down, this is upside down. Here we go. Here's a piece of metal drip edge over maybe a ledger board for a deck or some sort of projecting trim. This is a big problem, right? Carpenters come on a job, frame the walls, sheet the walls, roll out the Tyvek, tip the walls, put the windows in, they're gone. Who comes next? Well, usually some kind of sheet metal guy. Maybe my tinner comes to put gutter flashings on, etc. Flashings come. Well, the Tyvek's already there. I can't shingle this properly. This is happening every day, and we can't throw up our hands. This is backwards. Water's going to run down the face of this, and water's going to run behind this. This flashing that I paid a lot of money for has been defeated. And in fact is now the thing that's holding water inside my wall, letting water behind that piece of trim instead of down the face and over that piece of trim. Well, how do you solve that? Do you have the tinner come first? Not usually. But the tinner's got to understand he's got to slice that weather-resistant barrier. He's got to curl it back up. He's got to put his tin on, and he's got to lay that back down. It can be done. I'll show you examples of it being done. But we can't just walk away from this. We can't just go, well, I don't do it in that order. There's been some talk. You go to Texas, there are house wrap contractors. All these other dudes come and do their thing first. Framers, sheathing, windows, tin, everything's done, and then a contractor comes and puts the house wrap on. That would be a great way to do it. We probably couldn't afford it. But that would be the way to do it. This stuff should be on here last so it can be lapped properly. But there are ways to still achieve it. Just because I do things in a different sequence doesn't change the laws of physics. It doesn't change what the water's going to do. The water's not going to listen to the way I do it. The water's going to follow physics. Here you go again. Hey, go fix the ripped pieces of Tyvek. It can't go on over the face. Now water's behind it. Now it's driving water in. Same thing. I got a mix of materials. This stuff lapped up over the bottom of this cantilevered chimney chase with the top edge exposed. You can see the water dripping out of the bottom of it. Now it's holding it in. This is a Reside 10-year-old home. No wrap used, no window tapes used, raw OSB. Here's what it looks like. Here's what it looks like when it gets wet. It sits back there in the dark behind our siding, staying wet most of the time. That's what it ends up like very soon. You've all seen it. You've all seen the guy that ran out of money and his house sat there with exposed OSB for what, 3-4 months? It's starting to turn black. And that's with the sun drying it out. Imagine what it looks like now back in the dark behind the siding. It's a mushroom farm. These big gaps here between the sheeting and, again, this rim joist, that doesn't create a plane. You all know if you try to pour a pitcher of iced tea too slowly, the iced tea curls around the spout and runs down the side. That's the same principle when you got this big gap. It's running down the face, and now it's curling underneath that spot. It's going in. You can't change physics. All the product manufacturers in the world can't change physics. We have to respect and obey physics. Here we go again. My carpenter sheeted the gable ends. Now my roofer came. My roofer put the tins on. He put this really expensive, really nice Grace Vicor Plus over the face. Now one could argue that if that top edge stayed stuck just so and never let go, I might get away with it. But the point is, we're reverse shingling. You would never do that on a roof. Never, ever, ever do that on a roof. You'd do it this way on a roof. By nature. By common sense. By our DNA, we do it this way on a roof. We get to a wall, and we think this is okay. Slice the house wrap, peel it back, put those tins and tape on, lay the house wrap down over the face so the very face material is lapped and shingled properly. Same stuff. Yeah, this stuff is super expensive too. And it's super excellent product. But it's in the wrong order. It's on the outside. Here's an example of proper technique. These flashings. Anytime we join pieces together, we've got to have some overlap. We've got to build redundancy into these systems. We can't just make it. So this 6-inch overlap on this piece of gutter apron is a good idea. Exterior cladding. Again, they all leak. Exterior cladding is clothing over the skin. The skin has got to be, the skin can't leak. This goes for everything. This is, again, this issue that we created, this sort of guidance document for Commerce. And you know why Commerce can't adopt it and why we knew that, why we were writing it, why Commerce can't adopt it? Because how do you inspect for this? At what point do you do an inspection? Do you have a drainage plane inspection? Well, but I get my rough framing and stuff done before my flashings go on, before my cider puts a lot of the flashings on, so he would need to be there. It really became a practicality issue. So we couldn't just sort of make the state the police person of this process. We have to take responsibility as craftspeople, as those master builders out there in the field. We have to take the responsibility and do this because buildings are going to fall apart if we don't. Customers are going to have a bad experience with water in their house if we don't. And as Jim said, that is the #1 callback and complaint, period. That's the problem, is water getting into the assembly. So it's not impossible to do, but we got to think like the roof. So in here we're going to talk about roof design, the wall, most importantly, how do things come together. Flashing is used a lot of times to bridge those interfaces between dissimilar materials. And we'll talk a little bit about the exterior cladding. The real thing you need to know, they all leak. And there are different applications depending on what you're going behind. Like Jim said, if it's a cladding that's going smuck tight to the wall, I don't have this drainage space that I was talking about. So not only the plane, not only the drainage plane for the water to kind of run down here, but the drainage space. So here's whatever my cladding is out here, I got to assume water's going to go behind it, and I got to give it some room to do it. If I'm using a type of cladding that gets plastered right to the wall, there's not enough space. So these crinkled wraps that are starting to come out create that. By their crinkling, they create space for that water to run, hit a flashing, and get to the ground. Roofs. Again, we all know this. I don't know who that is, but that means we're not naming the source of our roof diagrams. We all know this in our DNA. We just really do. Underlayment properly shingled, metal in the valleys if you so choose, some other kind of material in the valleys that's going to, uh-oh. Wow. That's it. Thanks for coming. No, we didn't properly credit the source of our slides. Yes, sir. Wow, great question. It can be put on by staples, it can be put on by cap nails, but there are some requirements and guidelines as to your fastening schedule. Too many fasteners, and again, we give this to the junior member of the crew. What's their logic tell them? Hey man, a few nails is good, more nails is better, right? If you don't know how to tie good knots, tie a lot of knots. Not good. The other thing, especially with a pneumatic stapler, where the drive can be set. A stapler that's too aggressive, a nice wide crown staple, foam sheathing, bashing that house wrap in, but actually bowing it back, creating a little funnel and a divot in the plane, bad stuff. So staples have to be applied just kind of gingerly. They got to be applied to a flush depth, but not further, and too many can be bad. I'll let the Tyvek specialist comment.
Well, it's been a long time since I've been a Tyvek specialist.
Sorry.
Anyways,
Special than I am.
you know, the key to fasteners, to answer that, that's the proper application. I mean, the best practice application is to use a plastic cap, whether you're using a staple or using a nail, in any house wrap and any WRB. One thing you may want to consider when you're choosing that, the technology of you know, the DuPont, who created the category, uses a spun bonded olefin. And the purpose of a spun bonded olefin is because it seals up very well around a fastener when a fastener goes through the WRB. So the plastic film category, the perforated plastics, you put a nail through plastic, it doesn't have a fibrous material that seals up around it. So that's where, when choosing that house wrap, you have to think about the fasteners. There is a fastening pattern. Best practice is to use a plastic cap. Like Pete said about the pneumatic gun, a lot of guys are using pneumatic guns to throw this stuff up. I would recommend a regulator. I would back off the pressure because, as Pete said, you don't only see it in the house wrap category, you see it in sheathings. They put up the sheathing board. The guys are just going crazy with this pneumatic gun, and you see they're perforating. They're going right through it, and they're killing the skin of the sheathing board. Well, I guarantee if you kill the skin of your sheathing board, you're going to kill it in your house wrap. So you want to put a regulator on that gun. Part of that is training the crew. Back off that pressure, and be very careful on how you're putting your penetrations into your WRB. Best practice, plastic cap, but choose the house wrap that's going to seal around that, and that's why spun bonded olefins has been the best ingredient within all house wrap manufacturers.
What about siding nails? When you put up the siding, does that have
Yeah,
an effect?
great question. What about siding? You know, we got all these different fasteners coming in. Again, spun bonded olefin seals up really well. If you want to do a test, here's a simple test to show you, to give you confidence in house wraps. We're never going to make a product that's 100%. Okay, so we got to kind of understand best practice application based on building science of bulk water. The best choice is using a spun bonded olefin, seals up very well. Here's kind of the easy test to do. Take a canister of water, like a mason jar. Put a piece of your house wrap over it, seal it with water in it, tip it upside down, throw a nail in it. They do a very good job of sealing up around nails. The problem is when guys are, you know, it's flapping in the wind, they're not taping the seams. You got to use the system, you got to manage the system so wind doesn't start tearing it and start pulling against that, so you create a bigger hole like Pete's been talking about through the proper installation. This whole thing works by training everybody in the trade to drive proper installation. So you got to document the process, and then train everybody that touches the product throughout the process. And then follow the best practice. Okay? Yeah, thanks for the questions.
Yep, great questions, and it gets us back to this, you know, mythical world we all live in when we teach, that our wall is just this sort of one slab with some continuous surface on the outside. We didn't even talk about the fact that, well, you got to put holes in the stuff to put it on, and then the cider's going to come and put more holes in it. It's like we always talk about vapor barriers on the inside. Like, well, just don't hang any pictures in your house and you'll be fine. The reality is we poke holes in the stuff. And what you want it to do is to seal around that hole. And you want to poke a minimum effective number of holes in it. So understanding how all this stuff works. I'm not going to spend any more time on this. Like I said, we're pretty good at roofs. That's what a valley looks like. We wouldn't have that metal valley up over the top of the shingles just because that guy came later. Well, my shingler came first and my sheet metal guy was busy, he came later. You would never let him put that over the top. We do it on the wall all day long. We can't. Here's a woven valley. Here's step flashing up against a chimney. Here's an apron flashing leading down onto the roof. Here's step flashing or baby tins. And then again, that roofing material goes over those. Those tins don't go to the outside, they go to the inside. Oh, here we go. Outside the house wrap. So here's my drainage plane. Here's one reverse lap for it to go behind. Let's add a second one. In case we didn't get any water behind this one, let's see if we get water behind these ones on the way down. And then maybe any of it makes it past there, it'll land here, and then it'll go where it's supposed to on the roof. This is inside out. Yeah, but my Tyvek goes on first. You got to slice the Tyvek. You got to peel it out of the way. You got to put this wonderful assembly on. I guess I would question the wisdom of black first and silver later. I'd probably go silver first and then black later and then white at the end. Just remember, silver, black, white. Simple. We can end the class now. Not correct. See it every day. I send photos to the Tyvek people every day. Are you training these people? You're selling them your product. The nice thing that I see is that there's actually house wrap on the chimney. These people at least realize this is more than an air barrier, but how many times will you see a wood-burning chase that runs right up to the eave line with Tyvek on it, nice exposed top edge, reverse shingled again, and then from the eave up, it's bare naked OSB, going to get vinyl siding on the outside of it. Here's a wonderful skylight. Not seeing as many of these. And again, you guys will have copies of all of these in your slide packet, so I'm not going to take a ton of time. All showing proper lapping technique. The reason we have so many roofing examples is because we just fundamentally get it on a roof. And if we would just build a wall the way we build a roof, we wouldn't have any problems. Counter flashing in brick. This nice raggle cut right in here. That counter flashing, friction fit in there. Proper shingling. This step flashing, this tin is going to have an exposed edge. So we got to cover it. We got to get things properly lapped. How many of you guys are seeing that happening today? But guys understood it years ago. They just understood it by their nature. Here's a saddle or cricket on the back side of a chimney. Nicely done. Again, my weather-resistant barrier should come down over these flanges. I learned at one home building company something you can really, really help yourself out with if you're in these kinds of situations. Oversize your cricket by a foot. Take this thing and run it 6 inches past the side of the chimney on both ends. You don't have a lot of margin for error. The water that hits the cricket now has got to get and run right along these tins, and it's still running along the bottom edge of this chimney. Who says you couldn't just build your cricket? So from the back side, yeah, you'd see a little triangle either side of the chimney if you looked at it from the ground. But now that water flow is directed out here 6 inches away from both sides of the chimney. Simple solution. Intersections between building components. Again, one solid wall, duh, we get that, easy. The problem is our houses are built out of a whole bunch of different stuff. Okay, the famous roof line running down an intersecting wall, garage roof against the second floor wall of a two-story. We all picture it, vertical wall, roof running down, baby tins coming to a bottom edge, there's going to be a gutter here. How many times I can drive 2 minutes away to a neighborhood, vinyl sided home, and there's this ugly black line going down the siding right here. Because this flow of water that's running down the tins is running straight down, misses the gutter end cap, because the gutter end cap's a little bit away from this wall, misses that, sloshes down the vinyl siding. Who's seen it? Anybody seen it? The kick-out flashing. It's just the last tin with the bottom leg of it slit, and the tin is folded. Now we cut a vertical slit in the vinyl siding. It sticks out. The water now hits this kick-out, and it's dumped into the gutter 4 inches away from the end. Very good practice, very easy, time-honored system we sort of forgot. Well, that's going to look stupid. I'm not going to have that metal sticking out. Here's somewhere. No, I guess I'll show you another picture of it. There's an example. I've got a couple photographs of it. Once again, weather-resistant barrier, lap down over the top of the tins. Good practice. Kick-out flashing is easy. It's the same tin. Just slit the bottom edge, fold it, attach it. Cider's got a little bit of work to do to work around it, but it's going to dump the water in the gutter instead of letting it just keep on speeding down the face of the wall and miss the gutter. Roof and wall intersection, once again, tin shingles, weather-resistant barrier down over the top of the tins, roofing down over the top of the tins. Roof to dormer, same concepts. Again, you have all these slides. What is a weather-resistant barrier? Now, this is cobbled together from a few codes. There are some codes. There's some state codes. There's some national and international codes that actually specify it. Wisconsin doesn't. Right now in Wisconsin, you're totally good to go foam sheathing and tape the joints. But borrowing from some other codes, felt, meeting ASTM standards, perfectly fine. Lap it properly. Qualifying house wraps that meet or exceed performance criteria. We chose some performance criteria. Or other WRB that meet or exceed the performance criteria. We're not sure what those might be, but if somebody can come up, and basically what your performance criteria, there's two. One's a water holdout. So I take a sheet of this stuff and I spray water against it. How much goes through? Because some goes through, but how much goes through? And we want that to be a minimum amount. And then the other one of these is vapor permeability. If I do get water into the wall and then it dries and it turns into vapor form, like Jimmy said, molecule form, can it get back out? And there are not very many house wrap products that meet both. Bulk water, liquid water, rain can't get in, water vapor can get out. Vapor permeable, hydrophobic. So we set a minimum of 5 perms so that the vapor can get out. It can't be less permeable than the sheathing material, or I'm still trapping water vapor in the wall. Much less of a concern to us. Years ago we talked about, oh, you know, you got to let the vapor out of the wall. Much less of a concern to us than keeping the bulk water out. That's by far responsible for more of the moisture, translate mold problems in new homes, is liquid water getting in, not the vapor that we generate getting trapped in the wall assembly. Now, it might get into a cold corner in a closet and make mold on the drywall, on the inside of the room, but the stuff inside the walls, the horror stories, 2020, we tore the wall apart, there's black fungus in there, that's because of rain. That's not because I cooked a spaghetti and my house was too tight. But we talk about this, and I don't even know what the units are. If you're interested in those codes, again, National Code doesn't have a water holdout standard. We chose that as a standard, kind of reviewing several different codes for this weather-resistant barrier. There are a few house wraps that meet that. Here's all your permeance of building materials. Again, a chart that you can review in your materials. But it's kind of interesting to look at some of these things. Coated vapor barrier paper. Huh?
In our materials, that's what we get. So.
Ah, okay. Well, if you want a full-size set, drop your business card. We'll make sure we'll email you the slides. So you can see wallboard is pretty permeable, so we can get vapor into our wall. That's why we use a vapor barrier in Wisconsin toward the inside, because it's going to go through the drywall. We just want to stop it from getting into the cavity. And you can see, again, some of these wraps, how much they let the vapor, the stuff you can't see, go through. Okay, it's got to be installed horizontally. We always joke, you know, Tyvek's on there, and we always look at an installation. We go, you put the name upside down, it's not going to work. The water's going to run up. It doesn't matter which way the name goes, but you shouldn't run it vertically. You should run it horizontally, again, so that you can get this proper lapping application going around. So a lot of times, guys, people who do it as a house wrap trade, somebody that just does house wrap, they'll go with the stuff on a pole, and they'll literally walk around and unroll it and unwrap it around a house, and then cut the windows in after the fact. So horizontally, upper layers over the under layers by at least 2 inches. Everybody got this picture clear in your mind? Not like this, like this. 2 inch. That's the standard we came up with. Again, none of this is code. Some of this may make code in the next revision, is what we're hearing. So watch for it. Vertical seams, so where I do run the end of one roll over another, we want 6 inches. Rips, tears, or voids must be repaired using the standards established under application. Tape or not to tape. Let's face it, again, we don't want to see very much tape on the outside. If you use tape, use the best tape. Use tape that you know will stay stuck. Use tape that is designed to go with the wrap that you're using. There is no tape really designed to use with felt. I would use a very high quality, some kind of an asphalt impregnated rubberized tape on felt. I would never use duct tape for anything except sticking microphone cords to the floor temporarily. And the slogan of the American Duct Tape Council is, that'll hold it for now. So, right? So no duct tape. Tape is very useful. Make sure you're using tape that's got the same name as your house wrap, preferably, that's designed to go with it. There are tapes that actually will form a chemical fused bond and will become part of the weather-resistant barrier. That's good tape. Don't just use any old tape. Must be covered per manufacturer's recommendations and requirements. Some weather-resistant barriers lose their weather resistance capability if they're exposed to UV radiation, which comes from our sun. So impacted differently by the environment, 15 days to 3 months. We always get a cider on the stuff 15 days after we put it up. I don't know, but watch for that. Especially a lot of these foam sheathings break down fairly rapidly under UV, which is a good reason to use house wrap in the first place. Don't leave your foam sitting out there in the sunlight. 2 inches, 6 inches. Told you that before. Starting from the bottom and going to the top, then you're going to guarantee this lapping is happening properly. And it's never the initial application that's the problem. We work from the ground, we work our way up, they're lapped properly. It's the stuff that somebody forgot. It's the, we forgot this window, we had to go back and add it. Or we ran out, we had to go back. It's the stuff that happens after the fact that, well, I just patched it over the top, and that's where I wind up with these upside down lapping kind of situations. All the way up. If I got a porch extension or something, I got to get all the way up, at least behind where that's attached to the wall. Again, here's your 2 inch, here's your 6 inch laps. Up to or behind the soffit. Oh, we sold 9-foot first floor walls on that job, and we only buy our Tyvek in 8-foot rolls. Okay, put the top piece on first, put the top piece on last so you're lapping it properly. Get it all the way up to the top of the wall. It's got to come all the way down over your wall-to-foundation interface. This happens to be a fiberglass drainage board that's used both for insulation and drainage. Usually we're going to cover this with some sort of a decorative material, gray sheet metal or gray plastic, to make it look like exposed foundation. That's got to lap down over it. It's blowing in the wind. It'll make it. It'll make it. It's got to lap down over it so that water's directed, again, to ground. Here's a roof-to-wall intersection, same slide we saw before. There's that kick-out flashing. There it is in an EIFS application. It's not that ugly. It's not that stupid looking, especially when you know that it's there to keep water from behind the EIFS, especially EIFS of all claddings, which we know if water gets behind it and freezes, the EIFS just blows up. So this is extremely critical here. But that's what a kick-out flashing looks like in real life. Here we go again, expensive stuff and lots of it. Oh, look how high I went up the wall with the ice and water, boss. You proud of me? Well, kinda. And then I put the metal on the outside of that, and I see that every day. That system is inside out. Well, I wish these two guys could have been here first, and then the Tyvek could have come later. But in reality, we know that's not true. Our framers are putting the Tyvek on. It's the most efficient way to do it. You got to cut a slice right down here at the roof plane, then put this stuff on, then let the Tyvek lay back down over it. Wow, I don't know if I could make a statement like that, but whatever you're using for your weather-resistant barrier should be lapped and shingled properly. Not this. This. I might think about that. Come from here down and just put a layer and create a new drainage plane. Basically abandon this one. This is probably pretty functional. I might think about taping the top of these. And then I'd start right here, right from underneath the overhang, and drape a new piece down that's lapped properly. Yeah. Instead of do your best and caulk the rest, and, well, you know, give us a call if there's any more problems. I mean, it's a drainage plane problem. I would create a new drainage plane. I'd create a continuous, smooth surface for the water that's going to go behind that cladding material to run down. And it can run all the way down over the top of those tins, hit this roof line, hit my kick-out flashing, get in my gutter, and we go on with Christmas dinner. What else is missing? I don't know. Okay, here's a fuzzy photo, but here's where they've actually curled that stuff up, put those tins on, it's ready to be curled back down. Here's another good example of it. They've actually sliced the Tyvek, picked it up, put their stuff in place, and the Tyvek will lay back down. I'll say in practice, the one person you can get the most help from in life with this stuff is your sider, the person that's putting that exterior cladding on. You can charge them with being sort of the watchdog for improper applications of this stuff. We always had a rule in construction that by covering something, by covering up somebody else's work, you sort of implied that you were okay with it. You sort of took responsibility for it. You put drywall over crappy framing, you bought it. You put siding over a leaky wall, you bought it. You accepted it as an acceptable place to put your material over. So I think if we invoke that kind of theory and say, look, if it ain't right, don't cover it up, especially with an exterior cladding, because it's only there to look nice. Tell the sider, I now absolve you from all responsibility for keeping water out of my homes with your material. But if you're not satisfied that the stuff that's there before you is going to keep water out, don't put your stuff on, because I'm hanging you for it if you do. You can have your sider have a roll of that compatible tape that goes with your choice of weather-resistant barrier. Supply them with that for free. And say little holes, cuts, nicks, tears. I mean, your men are 8 inches away from the wall going up a pump jack looking. They're inspecting it more closely than anybody ever will. Here, I'll give you 20 rolls of this tape, please. If there's holes, nicks, cuts, rips, whatever, tape them up. Use the right tape. Tape them up for me as you go. Is he going to charge you for that? Not if you don't have him go back to fix leaks. So that person can be a critical player on your team. They'll be the last eyes looking at that weather-resistant barrier before it gets hidden behind the pretty stuff that leaks. Once again, we're all good at building a flat wall and putting paper over it. Maybe we put some holes in it with staples, and maybe we put some nicks in it, we tape them up. But what about when we got to cut big holes in it and put beautiful, expensive windows through, and we don't want to leak at Thanksgiving dinner? Penetrations. It'd be so much easier if we just built houses without windows. They'd be more energy efficient, they wouldn't leak. It'd be kind of dark and dull. Again, this is a standard that this panel that I sat on wrote for the MBA. This is best practice. Equal to or greater than a 2.5-inch diameter hole. So equal to or greater than a 2.5-inch diameter. We're talking your sump pump discharge, what's an 1.5 inches? So we're talking about things like exhaust fan terminations, where maybe you got a piece of 4-inch round coming out of there. There are flashing products that are made for that. Our standard says use something. Use something more than tape or caulk when you're putting that big of a hole in the wall. Integrated with the weather-resistant barrier. So if you do it prior to the weather-resistant barrier, great. The weather-resistant barrier guy's got to go around you. Not usually the reality, because the house wrap goes on with the rough framers. So it's everybody else coming cutting holes in his stuff, and it's got to integrate with it. After the weather-resistant barrier, you got to peel it out of the way, do your thing, lay it back down. Whoop, sorry. Right way and wrong way. Okay, less than 2.5-inch diameter hole. We're talking about the piece of conduit for a water meter remote. We're talking about a hose bib going out, smaller things that are poking through, a wire penetration for an exterior light fixture. Caulking's okay. Try to pitch anything that's an actual pipe. Try to have it run downhill a little bit rather than being a back pitch. Water's going to run back down the length of that thing. Here's a multiple manifold gas system, probably a multifamily unit or a commercial building. Get some sealant on those things. Here again, some penetrations in an EIFS or stucco system. Pitch to the outside. caulked in place. That might be a 2.5-inch hole. These photos, yeah, February 15th, 2006. We've gotten this all under control since then. So, classic. I'm cutting in a box for outside outlet or something else. What's the easiest way to cut Tyvek? Hammer claws, man. Right? Right? It's the most effective tool for cutting a house wrap. You know, I'd be thrilled to see somebody take the right tape and get a circle of tape around this thing. Incidentally, we're seeing tons and tons and tons of fairly low-grade caulks and sealants being used now to control air infiltration at these spots with huge impact. I'm amazed when I go into a new home that's under any kind of an energy certification program, Energy Star, or I can't even remember the other one, but how much sealing we're doing. Not only where the boxes penetrate through the exterior wall, but then in the little knockouts where the wires, the little tabs where the wires go into the boxes. We're greasing all those things. I mean, it's cheap painter's caulk. You're using it for air infiltration, but I'd be thrilled to see this thing pumped full of a nice low-grade sealant and then something done to make that weather-resistant barrier flow smoothly around that opening. Tears, tatters, holes, slow the raindrops down, increase the likelihood that the raindrops are going in instead of flowing smoothly to ground. This is not a plane. Flashings, we all know about drip caps over window and door heads. We also most of the time see them on the outside of the weather-resistant barrier, not on the inside. And most of the time we're just doing them because we think they must look really nice. They don't really look nice. They're there, again, for water to hit a horizontal surface and have a chance of running over the edge and being directed to ground. If this is on the outside, you just increase the likelihood the water's going to go behind it. Now it's in the door assembly. Okay, here's some fancy slides on putting windows in. And again, it all goes back to this, not this. Program over. So, this is actually before the weather-resistant barrier goes on. You'll notice this did come from Texas. And most of the job sites I've had the pleasure to visit in Texas, house wrap's the last thing. Goes on all specialty trade all unto itself. This stuff is already done. So I got a rough opening. I put my sill flash down first. Does the sill flash actually go into the screen and line the sill? Best practice would say it does. Then the window. Now I've got proper shingling here. Caulk behind the window flange before installing. Some would say don't caulk this. If water is going to be behind there, it can now drip out onto the face of this sort of apron or sill flashing. Then the sides, I'm still shingling properly. And then the top, again, proper shingling here. Now this is before a weather-resistant barrier, so finally the weather-resistant barrier is going to come and shingle over the top of this. Building paper applied over sheeting, bottom up. Here it comes. They're showing again black paper. They used a lot of black paper in Texas. And a lot of times you're not seeing sheeting. At least the last time I was in San Antonio 2 years ago, no sheeting. Felt paper right on the studs. Siding right on the felt paper. It's Texas, man. This is after the building paper is applied. Once again, most of us are using our framer to put the building paper on, so this is the world we live in. And most of us are using the framer to put the windows in too, incidentally, so at least that person can get these two processes correct. So here it is. I chop out my rough opening. I create these couple of angled cuts at the top, and my flap. I keep saying, you got to slice it at the roof, you got to flap it back. This is what we're talking about. Same thing, flash a sill, into the screen, line the sill with some sort of a sill flashing, good practice. Window unit in, overlapping, properly shingled, caulk behind the window flange, sides, top, flap the flap down. Just tape these ends so it doesn't blow away before your siding contractor gets there. See, you got proper shingling going all the way, maybe except for right there, you wouldn't have proper shingling. Again, this is all compromised. People ask, what's the perfect wall system to build in Wisconsin? I said, get the weather to stay 72, 12 months a year, and I'll tell you what it is. But otherwise, we're dealing with changing conditions. It's all compromised. You're doing the best you can. But you're understanding the physics that go into it. Where flashing joints must occur, flashings must be lapped not less than 6 inches and sealed. This sure sounds like code, doesn't it? It's not code. It's our attempt at giving some guidance and some prescription for best practices. You saw that picture of that piece of gutter apron, lapped 6 inches. Continuously at the top of all exterior door and window openings extending horizontally past the frame at least 1/8 of an inch on each side. So if I've got a door that's a 3-foot wide door and it's got a piece of brick mold over the top, they're saying I need a continuous piece of flashing over the top of that and going 1/8 of an inch past on each side. Now I'm going to run vinyl J channel around that. Well, what's my vinyl J do at the top at those 1/8 inches? I'd see those 1/8 inches cut and maybe folded down over the corners. But that actually is a code right now. Current Wisconsin code says your metal's got to go 1/8 inch on each side past the projection. And a projection is anything that sticks out of your wall. So a window that sticks out of the wall, the cedar trim that sticks out that goes around the window, 5/4 trim sticks out of the wall, FIPON material, keep going. Intersection of chimneys or other masonry construction with frame walls have to be flashed now. There's a window head flashing. Again, they're saying this goes 1/8 inch past that projection. That may or may not be practical. We already saw this, bad, 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 inside out. Foam sheathing, some black stuff over the face of it, some tins over the face of that. I don't know how much weather that's really going to take. I'd be more concerned and interested with what's happening down here, frankly, because this is sort of a classic dead valley kind of situation. Yeah, I'd let you leave that as long as I knew you did a good job managing what happened right there. But knowing that you left that on, I don't know, what's that, an $800,000 house? Knowing that you left that, I would be suspect as to what you did here. Anybody that can explain this, see me after class. Again, continuously above all projecting wood trim. So a belly board that divides first and second floors, any kind of decorative trim, anything that sticks out of the plane, again, that flat surface that we draw so well, anything that is attached to it and sticks out of it has got to have some sort of a flashing. I killed this marker by letting it dry up. It's got to have some kind of a flashing over the top, and then ideally, again, our weather-resistant barrier is out over the face of that. You guys are getting this. You guys are like, we know this stuff. There it is again. Porches, decks, or stairs attached to a wall or floor assembly of wood frame construction. Got to be flashed. Okay, here's a ledger board for a future deck. Got my metal flashing over the top. Got my Tyvek lap down over it, real nice. Here's a little placeholder. Here's a block that this must have been the guy who was going to build the deck, because he put this block in place for later. He can yank it out, and now his decorative skirt board that goes on the deck can fit right in there. So the cider's going to leave him the gap he needs. Well, that metal flashing should have come all the way out over that end, because that's going to be wood later. So some nice forethought, almost. That's what we said, deck ledger board almost properly flashed. The weather-resistant barrier properly cut and shingled over the flashing. Nice job. I don't know how that's fastened to the skirt, but we'll deal with that later. Need a flashing here. Oh, it's coming later. So some sort of a metal drip cap down over the tops of those joists, down over the top of that ledger board, and then a weather-resistant barrier over the top of the metal. I hope that's going to happen. Wall and roof intersections. We talked about that. Built-in gutters. Okay. This is the last slide. How are we doing on time? Oh, my God. Everybody's still awake? Smells like lunch is here? Okay. Are you taking this one or am I doing this one? I do it? All right. So, design a wall system that's forgiving. Again, figure on water going behind the pretty stuff that you see from the road. Just figure on it. The inspector says don't insulate till you put the siding on. Say why. The siding is not going to keep the water out of the wall. Design redundant systems. Design belt and suspenders type of systems for water. The problem is, again, the old drafty wall with no insulation in it probably was getting wet every time it rained. But we ran our old inefficient heating systems inside those structures, and that heat went where? Right out through the wall to the exterior, and it dried that moisture out. And the wall sort of didn't care, because as soon as it got wet, it got dry again, because the wind was blowing through it. Today, we don't do that. We build a very tight wall. We pack it full of fiberglass insulation. We put a vapor barrier on the inside. We put foam sheathing on the outside. Now when water gets in there, it's sitting there in the dark. It's sitting there in the dark, perfect conditions for a mushroom farm. That wall's cold. Think about that. We talk about what's the temperature inside a wall. Well, the best insulating wall is cold inside because the warm part is in where the people live. So that wall's cold inside. So moisture getting into a cold, dark place, what happens? We all know, we saw it in the basement. Cold, dark place in water grows mold. So you got to be really vigilant to keep water from ever getting in that wall assembly in the first place. Design redundant systems. Let diffusion drying happen where it can. Redundancies and protection. Remember the 4 Ds of water management. What are they? I'm embarrassed to say I can't remember.
I know 2 of them.
Drainage.
Durability.
Durability. Drainage.
Durability and drainage, times 2.
Durability and drainage squared. See me after class. Continuous air and water barriers. Watch for improper details. You'll drive home from here today and you'll see a job and the guy's putting the house wrap right up to the second floor plate line. He's leaving the gable end OSB barrier. You can't do it. Leave the house wrap off. Save the money. You're better off. You can't do it. Projecting chimney going above the roof line, Tyvek stops at the second floor, or Typar or Green Guard or whatever you're using stops at the second floor. Don't do it. You're causing yourself water problems. Do it all the way or don't do it. Let's talk about this for a second. I talked about that black OSB sheathing. What do we make our garages out of? OSB. Who's putting Tyvek on their garage? Who's putting house wrap on their garage? Good man. Yeah, you got to. You got, oh, I'm not heating it. I could save like $9 a house. Don't do it. If you're not going to put it there, don't put it anywhere. Save $900 a house if you want to save that. But if it's going to be on an exterior surface and it's going to be behind an exterior cladding that we can all agree water's going to get behind, make a weather-resistant barrier. Select products that help create an effective building envelope. We're not trying to push any particular brand here, but make sure you understand. If you just ripped an ad out of the magazine on the way to Vegas, understand why you're buying that, understand how it's going to work with everything else you're doing on the outside of your house. So, all right.
Well, thank you.
Thanks for your attendance.
Yeah, appreciate it.
Appreciate it.